Hello everyone. In this video, we'll be looking at another deterministic finite automata example. So in this example, we are asked to design a DFA with alphabet 0, 1 that either starts with 0 and is odd or starts with 1 and is even. So for this example, we've got two cases to work with. Case 1 states that the string starts with 0 and is odd. So if those two conditions are met, a string should be accepted. Or the string must start with 1 and be even, and then it would be accepted as well. So we're working with two cases now. But we should still just start with a simple approach, which is you start with the initial state, and then you build on top of it one condition at a time until the automaton starts looking full. So we're going to start at our initial state, Q0, and we're first going to try to represent case 1. So for case 1, the string starts with 0. So let's say you read a 0. And if the string is odd, it must be accepted. Now, if you went from an empty string to reading a 0, then you are at a odd length currently, because you've only read 1 0, and 1 is an odd number. Therefore, the state we're going to go to is going to be an accept state. Since if I was just given a string that was just 0, that string should be accepted. And this is the most basic representation of that. Now let's build on top of this. So we've got Q1. Let's see what happens if you read characters while you're at Q1. Well, if you're at Q1, we're assuming that you are a string of odd length. And if you have a string of odd length and you add another character to it, one character, then the string becomes of even length, because an odd number plus 1 is an even number. Therefore, if you read any character from Q1, it could be 0 or 1, it doesn't matter. You will go to another state, Q2, which is not an accept state because now it's even. The length of the string is even. And from Q2, if you read another character, again, regardless of whether it's 0 or 1, then the length of the string will be odd again. So you will move back to Q1. And Q1 is an accept state because it represents the string starting with 0 and the string being odd. And with that, we have a full representation for case 1. Now for case 2, the string starts with 1. Okay, so let's just do the same thing, but this time reading a 1. And we move to a new state, Q3. Now you'll see that Q3 is not an accept state. And the reason for that is because of condition 2.2, which is that the string must be even. Q3 represents an odd string as well, similar to Q1. So for a string to be accepted in case 2, it needs to be even. Therefore, you can't accept it on the first character you read, but you can accept it on the second character since 2 is an even number. So from Q3, if you read another character, whether it's 0 or 1, you will move to another state, Q4, which in this case will be an accept state. So Q4 represents the string being even. Now from Q4, if you read another character, then the string becomes odd, since an even number plus 1 is an odd number. So you'll move back to Q3. And with that, our automaton is complete. We fully represent now for both case 1 and case 2. And we can test it for some input strings. So if we look at 1001, that is a string that starts with 1 and is even, so it therefore should be accepted. And we can see, so if you start at Q0 and you read 1, you go to Q3, then you read 0, you go to Q4, then you read 0 again, and you go back to Q3. Then you read a 1, and you go back to Q4, which is an accept state. Then we have the next string, which is 0, 1, 0. So that is a string that starts with 0 and is odd. So it should be accepted. You start at Q0. You read a 0, you go to Q1. You read a 1, you go to Q2. Then you read a 0, and you go back to Q1, which is an accept state. Okay, our final string is 111. So that is a string that starts with 1 and is odd. Therefore, it should be rejected. And we can see that. So if you start at Q0 and you read a 1, you go to Q3, you read another 1, you go to Q4, then you read the final one, and you go back to Q3 where the string is rejected. And that concludes today's example. In our next video, we'll be looking at non-deterministic finite automata. So thank you for watching and Happy New Year.